So we've been learning to do the antiderivative, which means the backwards process of deriving. Okay, so this little symbol right here, kind of like a little longer s, is an integration symbol. So integration is the process of finding the antiderivative. Integration. So I'm going to integrate this function with respect to x. That's just the calculus words behind that. And then we talked about this word being like the indefinite integral. And then we were always adding plus c at the end yesterday because we don't know if there was a constant on there, because if we were to derive it, it was 0. So we don't know if it was there or not. So indefinite integral is just getting an equation. So now I'm going to show you how to get a definite integral, which is going to be not only the equation, but the actual area. Okay, so here's an example. So what we did on day 1 is we took this x squared function. So remember what this was all about. Y equals x squared is a parabola. And what I was doing was I'm trying to find the area underneath that. And this says from 1 to 9. So from the x value 1 to the x value 9, what is the area under the curve like that? That's what this would tell me. So your answer is that area. Okay. So here we go. We're going to do the antiderivative. So the integration means start the process of the antiderivative. So what do? We go up. So this is cubed. And then we divide by 3. Go up and then divide. Okay, now because I am doing this definitely, I'm going to go this square bracket and then say I'm going to do this from 1 to 9. Okay, now you plug in the 9, subtract, and plug in the 1. Okay, so whatever number that turns out to be. Let's see. Okay, I guess I've already filled in this example for you, but here's what I did on this example. So 9 subtract 3x, would you understand the visual of that is a line? Just an x is a line. So you can see that my y-intercept was 9, and then I went down 3, right 1, down 3, right 1, down 3, right 1. That's what this line is doing visually. So here's looking at my process. I did the antiderivative. So if I go up, I get an x. If I go up, I get a 2 and divide. So there's my antiderivative. And then I'm going to do it specifically from plugging in a 3, subtract, and I plug in the 0. And then you can see that that would all just end up actually being 0. So this became 13.5. And then I'm noticing something. Well, this is a line, so actually, you know what I could have done? I could have just done a triangle shape. So the height of this triangle was 9, and the base of it was 3. So base times height divided by 2, look at that, gave me the exact same area. Okay, so there are certain things with lines that you can do. Shapes, obviously you can't do that with curves, right? Okay, so here's what I did. 6 minus the absolute value of x. Do you remember what the absolute value of x means? Okay, so first of all, do you know what y equals x would look like? Just a line like that. Okay, then here's what I did. I absolute valued it. So if I absolute value a line, it would stay positive, zeros would stay, the negative would change, reflect. Now, this is all transformations from pre-calc. There's a negative multiplier in front of the absolute. So how do I graph with a negative in the front? Would that be an A or a B? An A. So I need to vertically reflect. So here's my V. Now it's upside down. Then I put a 6 number on this. So the 6 would make it move in a what direction? Up 6. So I took that and I moved it up 6. And then this question is asking me to figure out the area from negative 6 to 6. What's the area underneath it? So I can use shapes on this one because it is a perfect shape. Okay, so what's the base? 12. Height is 6. So I'm going to go base times height averaged. Okay, so I was putting in a little bit of your pre-calc, all your stuff with transformations, see if you remember any of that. Right, Tyson?
What?
Absolute values, reflections, shifting up. Okay, we are going to do this one using calculus and shapes because it's a line, so we can do that. So here's what I want you to do. Integrate this function with respect to x from 0 to 5. So that's how you would write the calculus definition of this. We're going to integrate the function with respect to x from 0 to 5. Okay, now do the antiderivative. So what do you do? How do you go up a degree? Right now there's an x0, so we would go up. And then 5 divided by 1, right, is just 5x. And we did the antiderivative, so I don't want the integral in there anymore, from 0 to 5. So now I'm going to plug the 5 in, subtract, and plug the 0 in. Okay, if I do this with a shape, so from the x value 0 to the x value 5, what is the area under this constant line? So what's the walls of this 5 by a 5? Did we match? Yeah. Okay, let's try a little bit more challenging ones. So those were some that you can do with shapes. Okay, here we go. So find the area. So find the integral of this function with respect to x from 2 to 6. Okay, here we go. I'm going to go up. So instead of squared, I'm cubed. There was a 3 there, divided by a 3. So just 1. I'm I'm going to go up. So I'm going to do that as a square. And I had a 4 there divided by the 2, so 2. And do you remember me saying you can check your answers by deriving? So if I did this, what's the integral, or what's the derivative? 3x squared. Yep. If I derive this, I get a 4x. So there's the antiderivative. So now I'm going to do that from 2 to 6. So plug in a 6 to the whole thing, minus plug in a 2 to the whole thing.
Does it matter if we just put cube squared?
Yeah, you know what? I probably didn't even write anything on it. Okay, I'm ready for the next one. Okay, this one might be a little tricky. We have to go up. So what would the original exponent be if we had gone up?
5/3.
5/3. What do you get if you, well, there was a 1 there. So what do you get if you do a 1 divided by that? One divided by that. 3/5. So you know what? Again, what do you do with your brain? You check. What's the derivative of this? What would you get if you times those? 1 and then lower. Good. We did it. And what's the derivative or antiderivative? If you have just a number there, that means there would have been a x on it. You have to go up 1, so up 1 is just an x. Okay, give me that square bracket because that means you've done the process. And you're going to do it from 1 to 4. Anybody match my number? No. Anybody? That's a hard type in for some reason. Anybody match me? Yes? No? You would have to do
I still get 30.4 no matter what. Yeah, no, but you kept it in my calculator.
Did you have like any of these separate values, or
I
you?
had the 26.
Oh, well, that's the hard part. And then you got something different on that one?
Yeah.
plus 5. Right? Because this would just stay as a 1. Okay, the last one here. Okay, do you understand I don't like the divide numbers, so I always switch them to look like that. Right? Because when we're doing all this process, it's like the coefficient exponent stuff. We like to see them separately like that. Okay. So ready? We're going to go up an exponent, so cube, and divide. So you had a 1/5. Divide by 3 makes 1/15. Okay, anybody have something with the 1 over? ln, yeah. Okay, what if you forgot? I'm going to show you if you forgot. So first of all, this would have been x to a -1, right? That's the original. So if you had forgot and you tried to do the 1 up, it'd be 0 and then divide. That's a problem. So again, you can't do that method. You have to memorize that the 1 over x is the ln thing. And you're doing that from 1 to 8. There's lots of fun typing, I guess.
Fun in my email.
Tricky typing. There's lots of tricky typing. Any matches on that?
How much brackets are you using?
Uh-oh. Close? Oh, that's what I got on the first part.
Yeah, I all got the same thing on the first part, and then when I added the second part, I got the same thing.
It didn't even change?
No.
ln of 1.
It's like 0.0. Like this.
So yeah, that is 0. This is 0.
Yeah, but then I also, that part, I also got 0 for 16.
You should get 1/15.
I hate everything.
There's just a 1/15 on that.
Yeah, I got it.
Okay, one more. Then we're done. Okay, I want to give you a red flag on this. Wink, wink. You guys know what my little red flags are all about? So I'm going to put this on the test, and here's what I need you to understand. You are integrating this with respect to x. So a is not a variable. A is a number. X is the variable, but a is just a number then. Got it? See the difference in your brain? Don't do the antiderivative stuff with respect to a. Don't do that. Okay, ready? So this one will be easy, just respect to x. So we go up to a squared. And then what's the 8 divided by the new thing 2? 4. Okay, and if this is just a number, what do? Just go up an x. Just go up an x. Okay, so there's where your brain gets tricked, because you probably are going to try to do crazy things with a. But a, don't drive stuff with it. Okay, so there you go, from a 0 to an a. Okay, so now I'm going to take this and plug an a in. So 4 times a squared plus 6a squared, plug in an a. And when you're doing the plug-ins, you're replacing x's, right? Everything's with respect to x. You're plugging into x's. Okay, so how did this seem for your brain? Does it kind of make sense? The a is actually just a number to make sure you don't derive with it or anti-derive with it. Okay, so this one should be easy. That's all 0, right? Okay, so what do we get here? We have 4a squared plus 6a cubed. And I think that would be the end. That's it.